Okay, welcome back. And so now we're just about finished with this lesson, but we do want to mention what a prominence is and what a solar flare is. So a prominence is going to be a magnetic field that is poking out of the sun. So you see where the magnetism in the left-hand side, you have a picture of the sun and you have the magnetic field coming out and then looping around and then going back in. So that's a sunspot where it's coming out and the sunspot where it's going back in. And then that magnetism can actually lift off gases from the sun. And so that's the reason why you can see the magnetic field, is because those are some of the gases that are being lifted off the surface of the sun. Now, in that picture there, look at that tiny little dot. That tiny dot is the Earth. So that would be the size of the Earth, a dot, in comparison to this gigantic prominence that is being released from the sun. So how is that different than a solar flare? Do you remember how we said that sunspots go away whenever they collide with other sunspots? And so their magnetism cancels out, and then this releases a tremendous amount of energy, because do you remember what was underneath the sunspot? It was all of this energy that was trying to get to the surface, but it was trapped by the magnetic field that was on top of it. So once that magnetic field releases, then all of that energy pops out of the sun in the form of a solar flare. And solar flares can be very, very dangerous. So if a solar flare was to come towards the Earth, it could interfere with radio communications. It could fry satellites. It could also destroy electrical transformers. It could cause blackouts. So solar flares are something to be very concerned about. But remember that it's a completely random event whenever a solar flare occurs. So the solar flare might go straight up, out the North Pole. It might go to the side. And so it would have to be pointing directly towards the Earth in order for the Earth to feel the effects of that solar flare. Okay, let's talk about the PP chain. So the PP chain is the way in which protons smash together and are turned into helium. Now, for my students in my astronomy, all I want you to know is 4 protons go in and helium comes out. So I don't want you to know in particular the steps of the PP chain, at least for the test. In your homework, yes, in your homework, you're going to have to know the individual steps in the PP chain. And that's shown in this picture here. I'd also like for you to watch this little video here, Proton-Proton Chain Nuclear Physics Animated Lessons on YouTube. So that goes through these steps involved in the formation of helium from 4 protons. Now, it will turn out that there are other ways of manufacturing elements inside of a star, in addition to the PP chain. But the PP chain is the one that I would like for you to know, because it's the one that converts hydrogen into helium. Okay, your appendix. For those of you who are saying to yourselves, you know, I'd certainly like to learn a lot more about calculus and about those 4 equations of stellar structure, well, here you go. So if you want to go ahead and look at this, this is kind of an explanation for where these 4 equations come from. So this is the first one, conservation of mass equation. Okay, here's the second one. So this one derives the equation for hydrostatic equilibrium. Remember, you can always pause me if you want to look at any of this stuff. And then here's the derivation of the energy generation equation. And then the most complicated one to derive turns out to be number 4. And so this is some pretty heavy-duty calculus in here. You wouldn't even do this kind of stuff until you probably went to graduate school. So don't worry if you don't understand it. Okay, and so here's the continuation of it. And then finally we do a whole bunch of substitutions and we end up with our equation for the radiative transport equation. All right, well, let's take one more break, and when we come back we'll do the lesson quiz.